So today we are going to illustrate the central limit theorem using this online Java applet. But before we go into the central limit theorem, let me explain you what the sampling distribution of x bar means. Suppose that you take a random sample from a population and calculate the sample mean. And if you do this repeatedly many times, calculate the sample mean each time and put them in a histogram, you can imagine of getting a picture that shows the range of possible values that x bar can take along with how likely those values are. And that's what we call the sampling distribution of x bar. So for instance, let's assume that the random variable I'm interested in is the time it takes for the Penn State students to come to campus. So this is the population distribution or the parent population. In other words, these are the times it takes for all the Penn State students to come to campus. It's a normal distribution and it has a mean of 16 minutes and standard deviation 5 minutes. So I'm going to go ahead and take a random sample of 2 students from this population and calculate their sample mean. So these are the 2 students and this is their sample mean. And I'm going to take another random sample and this is their sample mean. And likewise, let's take a third sample and this is their sample mean. And likewise, let's say I'm going to repeat this 10,000 times and calculate the sample means and put them in this blue histogram. And you can see this is what happens. This is a sampling distribution of x bar and it has a mean of 16 minutes and standard deviation 3.56 minutes. So let's go ahead and put this information in Excel sheet so that later on we can summarize. 16 and the standard deviation of the parent population is 5. It's a normal distribution and we took random samples of size 2. And if I calculate the sigma over square root n, it's equal to 3.53. And the mean of the blue histogram is 16 with standard deviation 3.56. And if you look at the shape, we can see it looks normal. So I'm going to write down looks normal. Okay, so let's go back to the applet and I'm going to change the parent population into uniform distribution. So this is a uniform distribution. It has a mean 16 and standard deviation 9.52. So I'm going to take random samples of size 5 this time. Let's take one random sample and this is their sample mean. A second sample and this is their sample mean. Likewise, let's repeat this 10,000 times and these are the sample means or the sampling distribution of x bar. And once again, let's go back to our Excel sheet and put this information. So the parent population mean is still 16 and standard deviation is 9.52. If we calculate sigma over square root n, it's 4.26 and the mean of the blue histogram is still 16 and standard deviation is 4.24. And if you look at the shape, it looks roughly normal. So once again, I'm not going to write down looks normal. Okay, so far we sampled from a normal distribution and a uniform distribution, which are of course symmetric distributions. So let's go ahead and sample from a skewed distribution and see what happens. So this is a right skewed distribution and this is the mean and the standard deviation for the population distribution. And I'm going to still take random samples of size 5, repeat this 10,000 times and put their sample means in the blue histogram. So here once again you can see the sample mean is 8.11. So the mean of the black histogram is 8.08 with the standard deviation 6.22, and it's a skewed distribution. The sample size is still 5, and sigma over square root 5 is 2.78, and mean of the blue histogram is now 8.11 with the standard deviation 2.76. But see what happened if you look at the shape. We sampled from right skewed distribution, and if you look at this blue histogram, even the blue histogram looks slightly right skewed. So let's put that information. Slightly right skewed. So now let's go ahead and increase the sample size and let's see what happened. So I'm going to increase the sample size up to 25. Do the same thing. Take random samples of size 25. Repeat this 10,000 times and put the sample means in the blue histogram. But now you can see that the blue histogram looks roughly symmetric. So once again, we're going to put this information into our Excel sheet. Population mean still 8.08 with a standard deviation 6.22. Skewed distribution sample size is 25, and sigma over square root 25 is equal to 1.24, and the blue histogram has a mean of 8.09 with the standard deviation 1.23, and if you look at the shape, we saw that it looks normal. Okay, so now we have completed this table. Let's compare the features of the black and the blue histograms. So if you compare the mean columns, so here you can see mean of the black histogram and blue histogram are pretty much the same. And at the same time, if you compare sigma over square root n with the standard deviation of the blue histogram, once again you can see that they are pretty similar. So to wrap up, this is what the central limit theorem tells us. If sample size is large enough, the sampling distribution of x bar becomes roughly normal with the same mean mu and standard deviation sigma over square root n, even if the parent population is non-normal. But if the parent population is normal, even for small sample sizes like 2, the sampling distribution of x bar becomes normal. And having said all this information, you have to keep in mind that in practice we take only one random sample. But the central limit theorem tells you what happens if you do this repeatedly, meaning that it tells you the distribution of x bar. So you can calculate all those probabilities using the methods that we learn in this class.